Hello everyone, welcome to this particular video. In our previous short video, we discussed about the statement of sandwich theorem, which can be called also as squeeze theorem. Now in this particular video, we are going to learn how to apply this sandwich theorem or squeeze theorem. Simply we are going to see how it can work in these example problems and how you can tackle this type of problems by using this simple trick or this simple sandwich theorem or squeeze theorem. So what does sandwich theorem or squeeze theorem imply? That if you have the three functions like f, g and h, the thing is like f of x less than equal to g of x less than equal to h of x. So for all the common domain of definition of these three functions f, g and h, if this condition holds that f of x less than equal to g of x less than equal to h of x, if this inequality holds for all the x, that is the common domain of definition of these three functions, then if you take limit at about the point, let's say a, so when x approaches to a, the limiting value of this function, if this becomes L, if x approaches to a, the limiting value of this terminal function, if it is L, then the middle one function will be tending to L as x approaches to this particular abscissa, that is A. So this is our simple sandwich theorem or squeeze theorem, that if you have the three functions f, g and h, over this condition or this inequality, that's f less than equal to g less than equal to h for all the common domain of definition of these three functions, and if x approaches to this particular value, if the first function, this lower function and this upper function tends to this value L, then the middle one function will be tending to L as f approaches to this same point, that is x approaches to a. So let us take this example on the basis of this. So sine of 2 by x, here 2 by x, 3 by x, whatever it is, then sine x ranges between to -1 to +1. So simply sine of 2 by x, that ranges between -1 to +1. Now let us multiply this by x square. So minus x square less than equal to x square sine of 2 by x. That is the desired thing, that you want to find this particular limit. So okay, so let x square. So let us take this limit as x approaches to infinity, minus of x square. So less than equal to limit x approaches to, so here would be 0, x square sine of 2 by x. Limit x approaches to, it will be 0, because if you want to apply this sandwich theorem, because it should be, it condition should be held over there. So x square, so minus of 0 square, that is 0. Here it is the main thing, that limiting value, whatever we have to find this value. Okay, so limit, that is L simply. So 0 square, that is also 0. So if this is tending to 0, this is tending to 0, the middle one function will be tending to 0 as x approaches to this particular value, that is 0. Over here is condition is held over here. So limit x approaches to 0, x square sine 2 by x, that will be simply 0 by using this sandwich theorem, by this using this squeeze theorem. Let us take another example. Limit x approaches to infinity, so sin x by x, same thing over here. You know the range of sin x, that is -1 to +1. Now if you divide this by whole thing by x, this inequality also holds over there. So limit x approaches to infinity, so -1 upon x less than equal to limit, the desired thing that we want to find, limit x approaches to infinity sin x upon x. The same thing goes over here, that is limit x approaches to infinity 1 upon x. The -1 upon infinity or 1 upon infinity, that always tends to 0. This thing always tends to 0 as x approaches to infinity, same point over here. So according to this sandwich theorem, this particular value will be tending to 0. So the answer will be 0 by using this sandwich or squeeze theorem. Let us take also this example. So here two function is here, so let us divide. So limit x approaches to infinity, let us separate the two functions according to the fundamental concept of limit. So x upon -2x plus 13 plus 7 sin x upon -2x plus 13, it could be separated by using the simple standard format of limit. So let us separate these, let us apply the limit on both functions separately. So limit x approaches to infinity, that is x upon, the denominator is -2x plus 13, and plus limit x approaches to infinity, let us take as g of x. G of x we are taking because for our convenience it is the big thing, so let us take this gx. So as limit x approaches to infinity, so you know the thing, when x approaches to infinity, the numerator and denominator the degree are same. So that is the coefficient of this highest term of this numerator divided by coefficient of this highest term of the denominator. If you don't know the rule, simply divide the highest value power of this x. So limit x approaches to infinity. So what is the highest value? That is 1. So let us divide it by x. So if you divide numerator by x, that is 1, and minus 2 plus 13 upon x plus it is as it is, let's say a. So 13 upon x, that is 13 upon infinity, that is 10 into 0. So minus 1 upon 2, that is the value, plus a. What is a? A is actually limit x approaches to, that is infinity. So sine 7 sine x upon minus 2x plus 13. Same thing over here, that is 7 sine x raised and equal to, that is minus 7 to plus 7. Okay, now divide this by using this. So minus 7 by limit as x approaches to infinity. So minus 2 into infinity, minus 2 into infinity plus 13, minus 2 times infinity plus 13, that will always tend to negative infinity. If you divide a negative value, then sign would be reversed. So limit minus 7 upon what is the value? Minus 2x plus 13. Let us reverse the sign. That is the desired limit we want to get, that is a less than equal to, what is this value? Limit x approaches to infinity, that is 7 upon minus 2x plus 13. Okay, so reverse it, sign would be reverse, or the same thing you can write is also reversely, so that things is not being taken care of, that is also always taken care of. So a, what is a? That is this function, this limiting value to 7 upon minus infinity or 7 upon plus infinity, that is always tending to 0, because 1 by infinity, that is always tending to 0. So middle one function will be tending